Hi, welcome to Visual Math. In this video, we are going to solve this interesting problem. Alice and Betty play an alternating, turn-based game where Alice starts first. The game starts with one red card, and the player takes turns to guess where the red card is. However, the game ends whenever any one of them guesses wrongly. Every extra turn, a black card is added to the card pool. Every time a player guesses correctly, 1 point is awarded to the player. What is the expected value of difference in points between Alice and Betty? Take a moment to pause the video and solve the problem on your own before moving on to the solution. First of all, we have to find all possible outcomes. That is, all possible differences in points between Alice and Betty. In round 1, there is only one red card on the table. It's Alice's round, so she will be certainly able to pick the red card and score her first point. In round 2, a black card is added to the card pool. It's Betty's round, and there could be two different outcomes at this point. Firstly, Betty could have chosen the black card and ended the game without scoring any points. In this case, the difference in points between Alice and Betty is 1. Secondly, Betty could have chosen the red card and scored 1 point, and the game keeps on. Moving on to round 3, another black card joins the card pool. It's Alice's round. At this point, there could be two distinct outcomes. Firstly, Alice could have chosen one of the black cards and ended the game. In this case, the difference in points between Alice and Betty is 0. In the second case, Alice chooses the red card, scores another point, and the game proceeds to round 4. In round 4, another black card is added to the pool of cards. It's Betty's round, and again, there could be two different outcomes at this point. First, Betty could have chosen a black card and ended the game with a 1-point difference. In the second case, she could have chosen the red card and scored another point. This would have brought the difference to 0. And the game would have continued with a recurring pattern in which the difference alternates between 0 and 1. Now, we move on to construct the probability distribution and find the expectation. We know the possible outcomes are 0 and 1. Then, we denote the probability of outcome 1 by p. This implies that the probability of the other outcome is 1 minus p, since the sum of all probabilities in a probability distribution is 1. Finally, we calculate the expectation as follows. Interestingly, the expectation turns out to be equal to the probability p, that the score difference is 1. In this final step, we are going to determine that probability p. Note that the event of obtaining a score difference of 1 comprises infinitely many sub-events. We will examine the first few to establish the pattern in their probabilities. The first case comprises two sub-events: Alice picking a red card in the first round and Betty picking a black card in the second round. In round 1, there is only one red card, so Alice is certain to pick it. Therefore, the probability of this sub-event is 1. By round 2, the card pool contains two cards, one red card and one black card. Hence, the probability that Betty picks the black card in this round is 1/2. Then, we find the probability of this case by multiplying the probabilities of the two sub-events, and the result is 1 over 2 factorial. Case 2, on the other hand, comprises 4 sub-events: Alice and Betty alternately picking red cards in the first 3 rounds, followed by Betty picking a black card in round 4. Again, in the first round, there is only one red card, so Alice is certain to pick it, with probability 1. In the second round, the pool contains one red and one black card, giving Betty a probability of 1/2 of picking red. In the third round, with one red and two black cards, Alice's probability of picking red is 1/3. Finally, in round 4, the pool contains one red and 3 black cards, so Betty's probability of picking black is 3/4. Notice that the probability of case 2, which is the product of the probabilities of all 4 sub-events, is 3 over 4 factorial. By observing the probabilities of the first few cases, we can derive a general expression for the probability of any case, where the case number is a positive integer. Then, we find the probability p of getting a score difference of 1 by summing the probabilities of all possible cases, as shown. Now, we proceed to simplify the summation and obtain a closed-form expression. First, we split the series into two parts, then simplify the first part as shown. Next, factor out the negative sign and rewrite both series as shown. After this, combine the two series. At this point, we introduce an extra term to shift the starting index. Finally, notice that the derived series is the Taylor series of the reciprocal of Euler's number. Therefore, the probability p, which is also the expected value, is equal to 1 minus the reciprocal of Euler's number. That wraps up today's problem. Thanks for watching and staying until the end. If you found this video helpful, don't forget to like the video and subscribe for more interesting math problems and solutions. See you next time.